Explanation of week 1 assignment of DBMS NPTEL. So first question asks us which of the following statements is correct. It's an 2-mark MSQ, that is multiple select question. So physical level abstraction describes how a record is stored. Yes, that's correct. View level abstraction hides the detail. That's correct. The third statement is incorrect because this description is given by logical level abstraction. It's given over here. Let's move on to second question. First question's answer is A and B. D is incorrect. Let's move on to second question. In this question, we are given two schemas, subject and faculty, out of which we have to find what is the correct relation between R1 and R2. This is the projection operator, and this is cross join. This is Cartesian product. So we are in the first R1, we are doing cross join and selecting, that is projecting subject, SID and SName. And in second one, we are doing Cartesian and then selecting the same attributes. So first of all, as I said in the previous lecture, cross join is a subset of Cartesian product, since we just select those entries where the attributes match on a Cartesian product. Hence, R1 is going to be a subset of R2, and that notation is given by this. Let's move on to next question. Okay, whenever you are given a relational algebra expression, start from the innermost bucket. So we will check the innermost bucket. It says a self-Cartesian product of schema mountain with itself, and this is the rename. The M mountain will be referred as M. So here, when we do apply this condition for selection, we get all the heights in mountain which are less than heights in mountain. So smaller heights, we project them using this. This projection is important since we are selecting the smaller heights and not the greater heights. And once you subtract smaller heights from all the heights, you get the maximum height. So option D is correct. Let's check this fourth question. The fourth question asks, it's given a relational schema of phone book which has 4 attributes as given. So if it gives us a tuple and ask that which of the following tuple cannot be inserted in the phone book. Now as you can see, the name and the phone book are the primary key here, so they cannot be they have to be unique and they cannot be null, so they have to be not null. All of the entries are not null, so we just have to find the unique entry. But we are asked which cannot be inserted, so we have to find which is duplicated. Here's the tuple which is present in an instance. So if a tuple is exactly same as this, which is option C, it is a duplicate at the primary key, that is the name and the phone number, hence it cannot be inserted. Here this tuple is duplicate at name but the phone number is different, hence it is allowed. So the answer is C. Let's move on to fifth question. Here again we are given a relation which has 4 attributes where flight number, source, destination, duration are 2 candidate keys. What is the possible number of super keys? So what are super keys? As I covered in the lecture, super keys are nothing but keys. That means the set of attributes which can uniquely identify all tuples in a relation. So there is a formula for calculating super keys. So for total number of keys, that is super keys, it is given as equal to super keys of flight with the first candidate key as the key only, and then the second candidate key as the key only minus intersection of both. So it's like the set formula where you do A union B equal to n of A union B equal to n of A plus n of B minus n of A intersection B. And the number of super keys is given by 2 raised to n minus 1. So for the first case, out of 4 attributes, there is only 1 attribute used as key, hence it is 2 raised to 4 minus 1. For second case, where 3 attributes are candidate keys, so we minus all minus number of attributes used as candidate keys, that is three keys, plus for the third one all attributes, that is flight and remaining 3 all are used, hence 4 minus 4, which is equal to given as 9. Let's move on to sixth question. For this question you will have to do a little bit of work. You will have to solve this logical expression and find this truth table. From this truth table you just have to find unique and not null values, which you can clearly see P and Q are going to be unique since the input. So you first have to find, first you can find easily that B option is correct, and for Q and R you need to check the relation. Let's move on to the next question, seventh question. Here we are given an instance of this schema, chat box schema. The center ID is the primary key. So if the same center ID is foreign key in this chat message schema, the chat ID is the primary key, we are asked which of the following is a valid instance of chat message. So first of all, since here center ID works as a foreign key, it should match exactly as the instance from the chat box. So we can easily filter out this is wrong since it doesn't match. This one also doesn't match, so this is easily out. So you just have to find out of A and B. Now you can easily see that chat ID is a primary key, so it cannot be duplicate, and since it is duplicated here, this is a clearly a wrong option, so B option is correct. Let's move on to next question. Now this is also again relational algebra question. We have to choose the operation that produces the following result. First of all, you can observe that the altitudes in the result are all some value greater than some value. You can go from the options. You can see 7750 is used in 3 options, so it has to be correct. You just check it out over here. These are the 3 entries that are given, this and this. So the answer will definitely contain 7750, so this is ruled out. Now in the first option it says that it is ANDed with Uttarakhand, so all the entries, the altitude is greater than this, and the entries have to be state name as Uttarakhand, but this tuple does not satisfy that, hence this is a wrong option. And in the second option it says or, but then in the original table there is a tuple that satisfies this B condition, but it is not seen in the result, hence this cannot be the option. C was already ruled out, so D has to be the correct answer. And you can already see that all the altitudes are greater than 775. Okay, let's see question number 9. Asks us again a relational algebra question. It asks us it is also giving us a result and asks us find the operation. You can clearly see that it is not the set difference, since if you subtract from say S1 minus S2, you will get some entry at J and K, but you cannot see it is in the result, so option A has to be incorrect. And if you subtract S2 minus S1, West Bengal cannot be in the result, hence B is also wrong. Now it has to be C or D. So let's quickly find out what is the intersection of M1 and M2 or S1 and S2. You can see the intersection is Kanchenjunga, Sandakphu, and here again Kanchenjunga and Sandakphu. Other than that, I cannot see anything in the intersection, and you can see it in the result. Now you cannot clearly see that the intersection is not in the option as only operation. There is something along with it, and as I have written over here, intersection with the union gives you intersection. So suppose there are 2 sets A and B, the intersection is given by this, and if you find the intersection with the A union B, suppose the rectangle is A union B, and you find the intersection, you will see it is equivalent to A intersection B only. So here's the last question. So for a key to be candidate key, it has to be unique and not null. You can clearly see that state name is not unique, so it cannot be candidate key. Here again altitude is duplicated, so it cannot be candidate key. Now candidate key can be only a single attribute or multiple attributes, that is name, comma, altitude, only name, altitude, comma, state name. All of the combinations can be candidate keys, but we have to choose from the options only. So only altitude won't work, only statement won't work. It has to be for mountain name and altitude, out of which you can clearly see mountain name is unique everywhere, so each tuple can be uniquely identified by using mountain name. And if you combine it with the altitude, I think it is correct, hence both of the options are correct. Okay, thanks for watching and see you in the next video.